Okay, so we're here back at the shop. We've been, if you've been following our different episodes with this 38 Zephyr restoration, engine building has been a major part of our thoughts and consideration. And we've been to a couple different builders and trying to figure out who can help us with the right timing. But in the meantime, we thought it'd be good to kind of explode the parts onto a table where we can see what they all look like, make sure we can inventory them clearly, understand how they go together a little bit better, and kind of take another look at what is involved in the Flathead V12 engine as far as parts go, how it's assembled. Some of you people are maybe a little bit interested like I am. And so we're going to let JB kind of walk us through, and he doesn't claim to be an engine guy per se, but he knows a lot. He's very modest about that. He knows a lot, and he will help us kind of identify some of this stuff. So come on along, and if you haven't subscribed, by the way, to our whole series, it's available, and this is part 18, so you've missed a lot. You might want to go back, and if you want to subscribe, we'll keep you posted as we go. JB, you have been kind enough to kind of put this all together on a table for me so I can see better, instead of the parts being in boxes, kind of what we have here. And maybe you can help us understand this V12 engine a little bit more and how it goes together.
Well, the V12 is real similar to a lot of engines from the period, and a lot of engines throughout history have really had mostly the same elements. Some had more cylinders, some had less cylinders, some had overhead cams, and some had cams in the middle of the engine. But I'll try to use English because, frankly, this is not my forte, but I've had to learn this because we're at the point now where we can't just dump the motor off and say, let us know when it's done. Because we bought a motor that had been machined and ready to be put together, and then they stopped. And since motors are becoming really precious, we thought it was a good idea to buy it because all of the correct pieces were in place. Some of this stuff was assembled back when the availability was a lot better for any number of the different elements, and we're going to go through them and kind of keep them in assemblies such that you understand that these are the rods. You might not want to try and memorize some of this stuff because it really isn't that important, but if you see the number of parts, first of all, you get an appreciation of how many parts there are here. There are hundreds of parts, so we're going to be just taking them in assemblies to kind of try and create a framework that will help all of us understand how this engine worked. And we did this for our own purposes, in addition to which we wanted to be able to explain it to other people who don't necessarily have a background in engines, and certainly not tearing one apart and looking at what all these elements do. So we're going to start with the oil pump. The oil to provide lubrication for the engine is made in such a way that it's driven off of the engine. And this is a pump driven with this cam gear. Down inside there's a whirling device that actually creates suction. It's pulled up through this to keep the sediment out, and
the pickup.
Right, this is the oil pickup, and you notice it has a screen,
okay,
which has got a little bit of dirt on it, so that's going to have to be cleaned up before we put it in service.
Okay. So when you mentioned this is a high performance oil pump, so
this is not a stock. This is not a stock oil pump. We're trying to create. Remember when the engines were first built, this was not available, so it's a very easy adaptation from a stock oil pickup to a high performance pickup. And obviously the more oil pressure you have, the more lubrication you have in the engine, and of course the easier the engine runs and the longer it lives.
So that was a good upgrade, and you want to look out for that upgrade.
Everything else we're going to see here is really pretty much stock, as it came from Lincoln. Okay, now we got a new set of bearings for our rods. Okay, those go right here. Okay. These are the rods, the 12 rods. Okay. You can notice that perhaps these have already been surfaced, and that these already have the bushings installed in them, so that part of the work has been done.
Okay, and just since you kind of gave me a rundown on this a little bit, so these are the locking washers
Correct.
that go on these bolts when
Right.
you're assembling them.
Right.
And what's interesting to me is that these little tabs here actually literally fold over the
Exactly.
bolt. So once the bolt is in and you fold that over, they're
Right.
locked. They can't move.
Right,
I
this
thought that
is
was
placed
cool.
right below the head of the bolt.
Uh-huh.
This is a two-piece assembly. If you notice, there's a
Right.
crack right there.
Yeah, so that's
All right, so this cap has
comes
to come
apart.
off in order to fit onto that crank.
Right, so
All
that's
right.
coming in right
So
there.
we're going to take it apart and put it
Okay.
back together, and in order for these bolts to not be able to come off, we put these keepers on there, and then
Yeah.
we bend the tabs up so that the bolts cannot rotate and
Yep.
come out.
They're not going to move.
So that really keeps that from happening.
Okay, so this is at the crank side, and this
Right.
is attached to the piston
That is correct.
side. So
That's
tell
correct.
us about the piston end of things.
Okay, this goes up inside the piston. So here we take a typical piston, and now we see the relationship. Okay?
Yep.
If you look down through there, you'll see that there's those
Yep.
holes line up.
Yep.
Okay? And that this is a pin that goes through here.
Yep. Called the wrist pin, I believe.
That's the wrist. That's the wrist pin. That of course goes through here,
Right.
and that ties those two things together,
Okay.
such that you have this relationship. Now this piston can now pivot as it goes up through the engine.
Right.
That
Okay.
this allows that movement to happen, and of course this is lubricated
Yeah.
so that the surfaces are lubricated.
Gotcha. Okay, now here we have some of the many pieces of the valve assembly.
Exactly.
And I love how you've got this set up where we can kind of see how these pieces are related to each other
Well-
when they're assembled.
When we first did this, we had everything just everywhere, and since we're not motor people, we didn't have any idea we had it all completely co-blended and messed up. So
Right.
we had somebody that knows how to build an engine. He said, "Look, this is the piston group, this is the valve group.
Right.
Okay, now
Right.
you've got the cam,
Sure.
and so we're trying to
So we're trying to make sense out of all of
yeah,
it.
it really is not a complicated device, but it's made up of a number of parts. So this particular item is what rides on the crank. I'm sorry, on the camshaft. The camshaft lobe, as you notice, is eccentric, and when it comes up and down, it causes this to go up and down. That's
It's
what
spinning around.
that's what operates the valves, and the valves, there are two kinds of valves. One allows the fuel mixture to come up into the engine. Okay, it exploded by the spark plug, and then we need a way to get the expelled gases out of the engine. So the exhaust valve opens according to the timing on the cam lobe, and allows those spent gases to come out, and then it starts the whole thing over again.
Right.
So it's a very, very simple device,
And
but it
these-
has to be very precise.
And these are hydraulic lifters, is that right?
That is correct. That's
Okay.
right. These are hydraulic lifters, and that you can look at these and tell that those are in fact hydraulic lifters.
Okay.
Okay, so you see the entire assemblage here, kind of an exploded view, shows you the relationship between the various parts in the valve. So this is the camshaft would be here.
Okay.
It's pushing up on that valve, and that valve is not going to do anything on the flat part of the cam
Until it spins to the
until
point
it-
where the
until it-
lobe is,
until it gets to this lobe, and that lobe opens that up,
okay.
and then allows it to close again exactly and precisely when the gas and air mixture has been introduced to the combustion chamber.
Yep.
It explodes, and then the exhaust valve allows it to exit and get rid of the spent gases, and then that goes out through the exhaust.
Now, maybe this would be a good time to just step over to that block
Okay.
and see how it relates to the block, because
Right.
you know, it's fascinating. We were talking about how incredibly sophisticated actually this block is,
Exactly.
because not only are the typical block, you know, has the cylinders for the piston to ride in,
Right.
but it doesn't normally have the valve
Exactly.
situation going on at
Yeah.
the same time. So there's an awful lot going on here.
Right. This was pretty much Henry Ford's idea of how to produce a large engine, a complicated engine, in such a way that it was very economical. Because if you recall the period we're talking about, right after the Depression in the early 30s, and engines, like everything else, had to be reduced in cost so that people could afford them, because people were hurting. You know, they didn't have money. It was a very difficult time in this country, and so he realized that he could not build an expensive engine in an inexpensive car. So in order for him to get more cylinders, more cubic inches, more power, he realized that he would have to innovate an entirely different way of building an engine. And what he came up with, and the people in the engine and engineering department came up with, was what's called a monoblock, which is essentially a block that you cast not only the bottom of the engine, but you cast the top of the engine all in one piece.
Yeah.
That necessitated the most sophisticated tooling on the planet. It was unheard of to have a casting that complicated. You got to remember, you're pouring molten metal into a mold with all of these different things having to be built into that mold. So it was extraordinarily complicated. I'm sure that they made a number of them that failed, and finally they got one that worked, and that was what became the famous Ford Flathead, which was around, started in late 31 and was introduced in 32, which of course is still right after the Depression, but it was the only really affordable V8 engine that was offered anywhere in the world, for that matter. And they increased their sales exponentially just because of it.
Okay, so let's go back to the table.
Okay.
And understanding here, I'll just get on the other side of this here.
Okay.
So all of this is going on inside the block. We don't have
Exactly.
separate heads to carry the valve trains like normal.
Exactly. So instead of having two separate entities, Ford was able to combine everything into one casting. So as you notice, everything here is a part of an assembly.
Yeah.
So that the amount of money it took to create all these parts was much less.
Yeah.
If you could do the engine in one piece,
Sure.
you could simply have all these pieces break apart and go back together. And as it turned out, of course, this engine doesn't come around until 36.
Okay.
It's in a 36 Lincoln Zephyr for the first time, and then as it grows and becomes more sophisticated over time, it was actually around for 10 or 11 years, and of course that interrupted by World War II. There was a 3 or 4 year period there where the V12s were not made. They were also used in generators. They were used in a certain amount of military equipment, and were of great use for a lot of reasons. One of the obvious benefits was it had more cylinders, which would create more power in a smaller area.
And it looks like 50% more parts with 12
and
cylinders.
coincidentally, yes. Now nowadays, of course, we've got 50% more parts to look for.
Right.
Really, the problem is finding and identifying where these parts come from, and some of them are reasonably easy to find. Pistons are not that difficult. There's a couple of companies making the reproductions. Some of the parts are shared with Ford Flathead V8s, which were made up until 53. Okay. So you've got 20 years of Flatheads were produced. It's a famous engine that was used in passenger cars and hot rods, race cars.
Yeah.
And so the interest in those has always been dramatically high, and so a lot of parts were created for the Ford Flathead, and some of those parts are shared by the V12, made by the same people. Some of them clearly are not. They look similar, but they're not quite exactly the same.
Right.
And but there are a number of them that were actually produced and are still being produced to take care of the thousands of Ford Flathead V8s that are still on the road.
Sure. Show me how this camshaft, how it works relative to the crankshaft.
Well, the V8 people
fit?
immediately will notice that this is a very long crankshaft.
Very long.
You know, you got to remember that an 8-cylinder would stop about here. So you got,
a lot of extra
50% additional cylinders to consider, and you got 50% additional devices to serve all those cylinders. So this is called the camshaft. This is the cam gear. This is what it rides on in the back of the engine. This supports the back of it. Okay. Okay. Doesn't do much else.
Yep.
And then the next thing we have in order of appearance is the thermostats. These go in the radiator hoses. This is a really early type of thermostat. You can see the metal, and as the metal heats, it actually turns and allows the water to come through at a different.
It opens that up.
It opens up this valve and allows more water to go through the motor.
Wow.
Okay.
Interesting.
This is the pickup that goes on the bottom of the pan to force the oil and make it go different directions. And then a stock. This is for a stock one. So in the case of we'll have to modify this slightly, but not a lot. This is the end piece that just holds.
It's the cam cover.
Exactly.
Okay.
This is the thing that goes out at the end of the crankshaft.
Okay, so that looks like a fan belt.
That's where the fan ties in. And this, of course, is if you look here, you got these springs, and this is a dynamic balancer, I believe is the correct name for it.
I guess the fan attaches to
The
that.
fan attaches to the outside of that.
Okay.
And draws cool air toward the engine.
Right, and then we have a full bearing set. We can see the front, and then the two center bearings, and then the rear bearing. They're different sizes. Right.
Now, various engines have various numbers of bearings because it's a 12-cylinder. Because the crank is so long, you really have to have a support in the middle. So these two middle guys are absolutely positively got to be there. Otherwise, the crankshaft could whip.
Yeah, it's so long.
Cause stresses on it. Yeah, so we got to have these 4 sets of bearings. This goes in the rear. This is like you said, these are in the middle. And these are the very important bolts that have, if you notice, they're called crown bolts.
Okay.
And each one of these allows you to put a pin across here when you got in the right position. You can put a cotter key, or you can put something in there that would keep this from turning out.
I think I've heard them called castle nuts.
Castle nuts, exactly.
One thing that's not shown here, but I'll point out, you talk about how long this camshaft is, and I'm noticing it obviously has some bearing support in the middle here as well.
Yes, it does.
But we don't have those shown here on this display.
Right.
But those would exist.
Exactly.
Wow. Well, obviously this is not every single piece for the engine, but it's a lot of pieces, and it's
close
really helping us understand how it goes together. This is really cool.
Yeah, when you're out looking for parts and you're talking to various suppliers, first place, the internet's not a really good place. Unfortunately, there are some commonly available stuff offered. This is a gasket set, and one of the things you got to remember about these is that when you put them on, they need to be put on cork to cork. They're not made to have the metal facing, which some of these unfortunately do. So you got to be careful not to buy one of those.
And we almost overlooked the rings.
Yeah, you won't overlook that. That's
it's still factory sealed.
Yeah, that's the holy grail of Lincoln Zephyr parts, because this is the actual parts made by Lincoln for replacements. And of course, this is this .040 refers to the oversize of the piston, so that you got to make sure that it relates to that, because this ring goes on that piston, obviously.
Right.
So they've got to be mated. If this is 30 over, these have to be 30 over. OS means oversized.
So, and again, for people who don't know, as an engine block wears, they will need to kind of drill out, you might say, in my vernacular, the bores of the cylinders to make everything smooth. They hone it out. And so by the time they get everything smooth, they've taken material out enough that you have to make a larger piston and larger rings to match to go in that space.
And normal wear and tear will cause an engine. The rings are sliding up and down inside the bores,
so that is
and they're literally grinding the cylinder bores. So that's why the type of lubricant you use and the quality of the oil pump is so incredibly important, because if you keep lubrication on those, we have engines now that will go 150,000 miles. These things will go 50 or 60,000 miles without any problem, but they got to be lubricated properly. It has to be the right oil. You can't use oil because some guy told you it was good in a race car or some other such thing. You really need the oil for these engines has to be a certain type. And it's very important that you adhere to that, and then you can get a lot of miles out of them. The whole idea of using hardened valve seats comes into play sometimes, and that really is where this valve seats into the engine and seals. As this goes up and down, it creates a seal. You can see it over there on the engine itself. Creating hardened valve seats is a complete waste of time and money, because we're not going to drive these engines, let's be honest, 60, 70,000 miles. So, and if you, obviously, so that's not a really good expenditure. This engine has been sleeved, which means that the cylinder bores that these pistons fit into were bored out, and then a hardened steel sleeve was slid down inside of it. And now it has a 40 over female hole to mate to the 40 over piston.
Right.
Okay, and it's actually, people look at sleeved engines as something bad. If it's done correctly, it's actually superior, because remember, that's a cast engine block, and with all of the porosity that an engine block can have, it's not an ideal surface to be boring out to accept a piston. So when you put a steel sleeve in there, again, important it's done correctly, then you actually have a superior motor that's going to last longer probably.
That's a really good point. I hadn't previously thought about that, but that's a really great point.
Yeah, but it's very important to be done
properly. All right, so I know this is a bit of an adventure we're on here.
Yes,
we're talking to different builders and different processes and finding all the parts. What do you believe? Now, I won't hold you to it, because again, it's an adventure. What do you think is the next step here? What are you thinking of doing next?
The last engine builder we spoke with said that we could save some time by going and getting the crank and the block that we've chosen, which are in excellent shape. They need to be stripped, chemically stripped, and then just cleaned up basically. And then Magnafluxed, which is a process where they put, I believe it's a material, it's like a powder, in, and they wash it onto the engine. And then they have a light that will actually pick up any kind of a crack in the cylinder block. And so it's a very inexpensive, very quick way to find out if we've got some cracks in the block that we really can't see visually with the naked eye. And that'll tell us if we got any problems. And those can be fixed. They can be welded. But we don't want to build the engine and find out we have cracks in the block.
Right. Make sure you got the right thing to start with.
Very good. Okay.
We'll look forward to the journey.
Yes, sir.
It'll continue.
Yes,
Thank
sir.
you.
You bet.